what happens is that we look at different processes and how the process models are here function. For example, we have history of processes and we have terms. How was programming viewed in the early days from 1940s to 1950s, and what changed from the 60 and onwards? So in the early days, programming was classified as a trivial task. Coding was equal to software was equal to code. Errors were seen as manageable, and from the 60s onward, systems and documentation should ensure that good low error software is created with acceptable effort. Typical view higher programming languages, for example Fortran, Algol, COBOL, and elementary programming rules solve the problem, but this only works for individual developers, not for projects with several people included. And when and where was the term software engineering coined? So the NATO conference in Garmisch-Partenkirche, where F.L. Bauer coined the term software engineering for the first time. Afterwards, in addition to programming in smaller context, large-scale programming gained in importance and attention. Procedure and process model were formulated and introduced for next necessary steps, and in 1970, when Wilson W. Royce, the waterfall model, in the 1980s, the quality of processes finally began to systematically assessed and improved. And we have what is the difference between a procedure and a process model. So procedure model contains the process model in it. Procedure model is just the it describes the basic procedure like the sequential or waterfall iterative example, and process has the procedure in it. The process has everything. The process has procedure and the process itself as well, so everything it has in it, and it includes several aspects including procedure model, organizational, structural, quality assurance, and project management requirements, etc. In a company, processes are defined on the basis of a process model relation on the slide. A process model is detailed in a process model, and we need to know that procedure model is a subset of process model, and that goes to concrete company processes. So the process, we have a three-level picture twice: the project and the product development. Which general process models from project management does the lecture name? We have sequential, we have overlapping, we have iterative. So sequential is linear, overlapping is parallel, iterative is repetitive. So which typical processes in software development does we cover in order? We first have code and fix, we have second is waterfall, third is V model, fourth is W model, fifth is V model XT, sixth is UP, undefined process, 7 is XP, extreme programming, 8 is Scrum, 9 is Kanban. XP, Scrum, and Kanban are marked as agile, so we know this. And then part 2 we have code and fix, waterfall, V or W model, V model XT. Then we have defined code and fix. Code and fix, aka quick and dirty, refers to a procedure in which coding or correcting alternating with ad hoc tests are the only consciously performed activities in software development. We know code and fix, why is it used and what are typical problems. It's used because it's relatively simple. First, executable program is created quickly. You have the feeling that you're making fast progress, but the disadvantages, what are the typical problems? The disadvantage is that program structure is often poor, little documentation, mostly in hands of the people involved. Requirements were not systematically collected. Target specification for test files. Then we have low predictability, high revision effort, distributed ad hoc work difficulty. And based on being able to describe the waterfall model and its notation, how would you describe it? Then the next question is, how would you describe the waterfall model and its notation? So represents the software development processes as a sequence of phases. Because of the cascade from one phase to the next, the model was given the name waterfall, originally published by Royce. Rectangles are activities phases, down arrows are desired transactions, arrows upward are back if errors are detected and needed to be rectified. There is no way operation back to development. So phases in like system analysis, software specification, architecture design, fine granular design and implementation, integration and test, then deployment and acceptance, and operation and maintenance. So there is no way from operation back to development. So down arrows desired transition, arrows upward jump back if errors are detected and need to be rectified. So we can jump back in one stage from here to here, but once we go here we cannot go all the way here. So it's like a waterfall going up to down. So the first is system analysis. You analyze software specification, architecture design, fine granular design and implementation, integration and test, deployment and acceptance, operation and maintenance. This was the waterfall and it's 7 steps. Was the waterfall originally meant to be strictly sequential? No, strict sequence was not intended. Steps back are also included in the original model. Historically, they were more and less omitted. A strictly sequential model has become established in linguistic usage. What has unfortunately been created and practiced is a one-way street model. Is the waterfall model Royce's fault? Now, Royce included steps back. Practice dropped them. So he did included the steps back, but the practice, the way we started to practice them, it unfortunately became a one-way street model instead of what Royce said. Now, evaluating the waterfall model against the 4 discussion criteria. High quality. How well is the quality supported? Strong dependency on early phases. Requirements elicitation is important, and late testing are bad. Then how well are customers satisfied? Is how well does it ensure usefulness for user? Late implementation, late tangible result is bad for communication. Maintainability, how well is efficient development and further development supported? No special features, further development is not the focus. Cost and time, how well is resource compliance supported? Criticized as above. Late testing is late results drive revision cost. These are 4 criteria. High quality, satisfy customer, maintainability and cost are applied to every model. Now we are able to know that in terms of waterfall model, the quality is not that good, because we can see that just like looking at other model is that, for example, strong dependencies on early phases. So early phases are strongly dependent on early phases, and late testing is generally a bad thing. Then we have satisfied customers. How well does it ensure usefulness? Because we have late implementation, the tangible result is bad for communication. This is why it also goes one step, not very good for high quality, not very good for satisfaction. Maintainability, no special features. So further development is not the focus. So maintainability is also not the focus. Cost and time, late testing, late result, revision cost. So it's also not very good for cost, because criticized as above. Late testing, for example, because we test very late, the late result driven revision the cost. So it's basically not good for any 4 of these criterion. Then the V model, which 2 things can be meant? Clarification of terms. The V model by Boehms is a sequential model shown in the V shape like this, and the German federal V model developed on behalf of the federal ministry. So these are 2 different things. Explain the structure of the V model. Further development of the waterfall model. The Boehm's V model is just the extension of the waterfall model. Even if the illustration suggests otherwise, the V model is a sequential model. Left side of the V is constructive branch. Requirements are becoming more and more detailed, increasing in level of detail. And the right side of the V is the analytical branch for testing and integration activities. Each level of the left branch is assigned a corresponding test level on the right arm. Integration on the right, for example. Typical V-shaped procedure. Requirements definition, rough draft. So for the V model, we make requirements definition for the first, rough draft, then we make detailed design, module specification, and then the coding. This is the left side of the V. Then coding is here. Then a right branch starts, module test, integration test, system test, acceptance test. Horizontal links are output, verification, and top level link requirements. Acceptance is validation. So we need to define verification and validation. Verification, confirming by providing objective evidence that specified requirements have been met. Are we doing it right? Are we doing it right, or are we following the blueprint right, the requirements? Validation, confirming by providing objective evidence that the requirement for a specific intended use or application has been met. Are we doing the right thing? So is it usable? So usable, requirements fulfilled. Then so the V diagram validation sits at the top level, requirements definition, acceptance test, verification at the levels below. What does W model add to the V model? Now what does the W model add to the V model? Further construction to the W model, preparation of the test activities parallel to the constructive branch. The W shape overlays two V's. Develop goes to prepare test goes to perform test goes to debug. And for every constructive level, requirements definition, functional system design, technical system design, component specification, there's a parallel prepare test activity, followed by later by perform test plus debug at the same time. So this is a W model. It adds to the V model, and it's pretty much develop, prepare test, perform test, and debug. These are the four phases of the W. Then we evaluate the VW model against four criterion. So high quality is very positive, support through early quality assurance planning, satisfies customer. So the quality is positive, it's good. Satisfied as with the waterfall implementation. Evaluate the VW model against. So as with waterfall implementation is too late, no prototyping, no so even the customer are not very satisfied. Implementation is way too late, we don't have prototyping and iterations. Maintainability is also not there because there is no special feature. Cost, early quality assurance planning helps resource efficiency. So we have good cost and time optimization because we have early quality assurance. Then we have outline the history of the German Federal V model, developed on behalf of the Federal Ministry of Defense and further developed and mandatory since 1992, later also on behalf of the Federal Administration and the Federal Ministry of the Interior for the civilian sector. There are three main versions. There's one that says software development standard of V model, then we have V model of 97, then we have V model XT 2005. So V model had these three versions. Then we have V model 92 and 97. So processes of software development projects from contractors perspective include submodels, whereby submodel was described in a V shape contributed to the name. What changed from V model 92 97 to V model XT? So V model 97 system and hardware were development was focused. So V model 97 was basically focused on that. Then V model XT was focused on flexibilization of procedure. No more sub models developed by a consortium of universities and industries. XT is extreme tailoring, allows the model to be adaptive to a specific framework condition. And we had first publication in 2004 for this, developed for the federal IT. Then we have overview of documents, decision, and all of this. XT stands for extreme tailoring, and also note that this is the more bureaucratic. So if it was easy, the V model was also done by German government because it was quite bureaucratically easy. Now we evaluate the V model XT against four criterion. It's high quality, early quality assurance planning with V model, satisfied customer, depends on the implementation of course, but still we have satisfied customers. Maintainability can become very bureaucratic if necessary. Cost and time, it's very bureaucratic of course, and document heavy, customizability for project possible, possibly complex. So we know that the quality is good. It depends on the implementation strategy. Either we apply agile to it or not, and it can be maintainable. It can be very bureaucratic. Then we have up model, the unified process. We need to give the background and definition of up. So OOP became popular towards the end of 80s. Realization that previous models did not fit the new paradigm. Published after further development stages in 1996, RUP is a version of the generic UP developed by IBM. So we need to name and describe the 4 phases of UP. Basic concept: inception. We have product idea, feasibility, understanding, rough draft, business cases. We have elaboration, refined vision, missed requirements, core architecture, effort. We have construction, implementation, integration, testing. We have transition, delivery, piloting, stabilization. So first phase was inception for up, second is elaboration, third is construction, fourth is transition. What are workflows in up? So workflows combine related activities. They are carried out in all phases only with varying intensity. The hub chart plots each discipline's intensity across the phases. Disciplines in the chart: business modeling, requirements analysis and design, implementation, test, deployment, configuration and change management, project management, environment. Then we have what are iterations and increments in up. Basic concept 3 and 4. So iterations: each phase can be subdivided into several iterations. In each phase, the artifact relevant to the phase are developed incrementally. Each phase is concluded with an internal milestone. If a product is to be delivered in expansion stages, the development cycle is run through several times. Prototyping is possible. Now we need to evaluate up against the 4 criterion. High quality: the quality is very high. Quality assurance, even if with varying intensity, is part of every phase. Satisfied customer: support prototyping. It is satisfied customering. We have supporting prototyping. Maintainability: we have focus on architecture modeling. Then we have cost time. Iterative development is explicitly supported. We need to then we look into Agile Manifesto and XP. We need to state the 4 value pairs of the manifesto for agile software development. Some state and the 4 pairs of manifesto for agile software development. We know that it's pretty much obvious that we are uncovering better ways of developing software by doing it and helping others do it, of course. And through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. Code in the closing to the manifesto does not say the right hand items are worthless. The nuance is standard follow-up, that these on the right hand are more valuable than on the left hand. So these are 4 value pairs of manifesto for agile. We can go ahead and to look into what is XP called. XP is extreme programming. The most influential work that has changed the culture of software development is XP, the book by Kent Beck, published in 1999. Extreme because previous good practice, iterative software development, has been taken into extreme. Regular interaction was known as good practice to find errors quickly. XP suggests interacting several times a day. Name the XP practices from the lecture and describe each. For example, planning game, constitution between customers and developer to determine the scope of the of the next increment. On-site customer competent representatives from the customer side are with the developers throughout the entire development period. Then we have collective ownership. Code belongs to the entire development team. Everyone is responsible for the code. The team reallocate cyclically. Then continuous integration, code produced by different teams members is merged very often. Then we had these are different XP practices from the lecture. For example, these are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first was planning game, second was on-site customer, third is collective ownership, fourth is continuous integration, fifth is pair programming, sixth is refactoring, seventh is simple design, eight is short increments, 9 is unit test, and 10 is coding standard. So let's deep dive into on-site customer. Competitive represented from the customer side are with the developers throughout the entire development period. Code belongs to the entire development team. Everyone is responsible for the code. The teams rotate cyclically. Then we have continuous integration. Code produced by different team members is merged very often. Then we have pair programming. Two developers work together on a piece of code at one time. Then we have refactoring. The code is restructured as early as possible and on a regular basis. Then we have simple design. No unnecessary features are implemented. We have short increments, frequent incremental delivery of the system with maximum value for the user. We have unit tests. The smallest unit are tested automatically. Coding standards, strict adherence to the coding guidelines. We know that shows that exactly 10 practices, count and name them from this. Now we have to explain the pair programming in detail. The pair programming, two developers sit at a computer and work together on a task. The two developers take different roles. Pilot writes, navigator thinks along, navigates, checks, thinks more about alternative solutions. The role changes regularly, for example, every 15 to 30 minutes. We have advantages, knowledge exchange, quality is increased, dual control principle, skill building, errors are recognized earlier, etc. We have Scrum then. Characterize Scrum in 4 points. We have Agile framework, provides a loose framework. We have empirical, so we have to characterize Scrum into 4 different points. The first is Agile framework, second is empirical, third is lightweight, fourth is value based. So provides a loose framework as Agile framework. Then we have empirical, an approach based on empirical process control, and lightweight only requires a minimal set of rules. And we have value-based. Cooperation is not based on sophisticated processes but on values. So what is classical and when agile project management is appropriate? So there are two axes: requirements, what, known clear versus unknown unclear, and solutions, technology, how. So this is the classical and when agile project management is appropriate. It's Stacy style matrix. So we have what, question mark, two axes of requirements: what, known clear versus unknown unclear, and solutions, technology, how, known clear experience versus unknown unclear no experience. What and how known clear is easy, classical project management. What or how unknown unclear is agile project management. Both extremes, unknown unclear no experience, leads to chaos. So either one is good and second is good, or if you don't know either of these, then it leads to chaos. What and how known is clear, easy is classical and what and or how unknown is unclear is agile project management. Then we have to explain empirical or process control, the theoretical foundations of Scrum. There are 3 fundamental concepts: transparency, inspection, adaptation. For successful completion of complex project, the current state of the solution must be transparent at all times, developed and inspected in small regular steps, and be able to adapt in small regular steps. Transparency is important. Results are visible and therefore available. Time boxing, results available at regular, closely timed points in time. Inspection, acceptance, criteria for the acceptance for an intern result. Status is not regularly queried and reported upward but checked daily. Then we have adaptation, to adapt, continuous learning and adaptation. We need to explain the principles of empirical process control using the example of Scrum. We need to be able to map each concept to Scrum element, transparency, board increment and inspection, and review, adaptation. Then we have retrospective. You need to name values of Scrum. We have openness, we have courage, we have focus, we have respect, and we have commitment. We need to exercise on the slides, being able to discuss the Scrum processes. Each value is particularly important. Now, how many roles, artifacts, and events are there in Scrum? Now we have 3 roles. We have product owner, we have Scrum master, we have team. Artifacts are product backlogs, sprint backlogs, product increments. Then we have 5 events: sprint planning, daily Scrum, sprint review, sprint retrospective. We need to describe the role of the product owner. Is responsible for product vision. He has no technical ability. He is able to do product vision, product strategy, product visionary, responsible for the budget, responsible for economic success of a product, identifies all stakeholder requirements, defines and prioritizes requirements which are recorded in a product backlog. It creates a release plan, accepts and sprint results are and the end product. Then we should describe the role of the team. All persons involved in development of the product, whether software, explanatory, video, training service, shares the task in order to implement the requirements in the given priority, breaks down the requirement into so-called tasks, commits to implementing a set of requirements by the end of the sprint. We have interdisciplinary compositions. We have self-responsible and self-organized in the sprint. Team consists of 3 max 10 interdisciplinary members, has all the skills to create a product increment, organizes itself, no prominent roles, positions and hierarchies. Then we need to describe the role of Scrum Master, responsible for the processes, responsible for the correct implementation of the Scrum process. We have values, we have roles, we have principles, we have coaching role. We have these are the roles of Scrum Master. Protects the team, removes obstacles. Immunities, product owner and Scrum Master never in personal union. So product owner and Scrum Master never in personal union. Can the product owner also be Scrum Master? No, never in personal union. This is the thing. So a product owner cannot also be like the Scrum Master at the same time, because the Scrum Master is responsible for the processes, values and principles, coaching, protecting the team, removing obstacles and things like this. Then we have what is the product backlog and how is it fulfilled. Contains requirements for the product, is prioritized by product owner and estimated by team. Priorities, estimates effort in the nutshell figure. Scrum does not specify how requirements should be described. Describing the backlog in the form of user stories have proven successful. Scrum in a nutshell is vision goes to product backlog, goes to sprint with daily, and product increment goes to review demo with stakeholders and the retrospective. Feedback flows back into the backlog. Then we need to describe the sprint and sprint planning. Product development takes place in iterations in sprints. Sprints have the exact length, maximum 4 weeks, typically 2 weeks. Content of sprint is defined in sprint planning. The high priority elements are taken from backlog. Team commits to implement within the sprint. The result is a finished product increment. The team determines how much content of the backlog is feasible in the sprint. The content to be implemented is recorded in the sprint backlog. The content of the sprint cannot be changed during the sprint principal pull. Now, what happens in the daily scrum? The team meets daily for the so-called daily scrum. Time and length of the meeting constant. The questions are: what have I done since the last daily scrum? What obstacles do I see on the way to my sprint goal? What do I plan to do before the next daily scrum that will bring us closer to the sprint goal? These are the different questions. Then we have participants like Scrum Master, team, PO optional. Now we have what are the sprint review and sprint retrospective. How does Scrum learn? We have a sprint review. Interim results are shown in the sprint review demo. Participants can be all stakeholders. The finished increment is approved by the product owner. And we have sprint retrospective. Every sprint ends with a retrospective. Here the team reflects on what went well and what went less in well. In the sprint, the Scrum Master operates the retrospective. We have learning, an essential part of Scrum. Inspect and adapt. The Scrum Master is a coach for the team, ensures compliance with Scrum rules, time boxing, etc. Supports the team in identifying, removing obstacles. Obstacles are identified in the daily Scrum and removed if possible. Obstacles hinder work in the current sprint. Then we distinguish definition of done, DOD, and acceptance criteria. Definition of done describes the team quality requirements for the increment quality gate. When are we finished? Example, when we have carried out all the test cases, when the documentation has been updated, when code reviews have taken place, etc. Then we have acceptance criterion, describes criteria that led to the acceptance of the increment by the PO, often referred to as acceptance test cases. DOD, definition of done, is team quality gate, applies to every increment. Acceptance criteria, PO, acceptance condition per requirement. Mixing these up is a common slip. So we know that definition of done is team quality gate, applies to every increment. Acceptance criterion is PO, acceptance gate. It is the acceptance gate of PO. Mixing these up is a common slip that a lot of people do. Then we have to evaluate XP and Scrum against the 4 criterion. It's high quality. It's very good through quality assurance practices, acceptance test cases, acceptance criterion, unit text, continuous integration, and Scrum as quasi standard in DOD, definition of done. Satisfied customers because we have good communication. On-site customers, XP, product owner, Scrum. Maintainability, XP has many good practices but too little documentation. More documentation with Scrum, but too little for long-term development. Cost and time, very good for cost time practices such as 40 hours per week. XP, time boxing. Scrum, too little structure for very large projects. So basically we have a Kanban origin. And so what does Kanban come from and what does the word mean? Originally from industry manufacturer, first used in the Toyota production system. Until then, individual process step of production processes were optimized. Kanban aims to optimize the entire process. Kanban is equals to signal, ban equals to card, order slip triggers production process. A signal Kanban is sent to the upstream location. When parts are required, only then are these parts produced or provided. The card is therefore a signal to produce more parts or to stop because these is enough. Decentralized production control, first introduced by David J. Anderson outside of the production information technology. Then we go ahead and we explain a barista example. Demand controls the production processes, material flow. A downstream processes ordering coffee. Tells the upstream processes making coffee that new parts coffee are needed. Typically, the barista receives Kanban's orders, for example, which they process. Rarely is production on stockpile. No parts are produced without a Kanban signal or order slips. Then we have what does Kanban do in knowledge work and what are the 6 core practices. It controls the invisible amount of work in a system, which is made visible by signal cards. In general, no specification how something should be done, rather what should be done. Core practices in knowledge work: make work visible. Secondly, limit the work in progress. Third, manage the flow. Fourth, make process rules explicit. Fifth, implicit feedback mechanism. Sixth, carry out joint improvements. So then we go ahead and we practice make work visible. How is Kanban board set up? Kanban board works with boards on which the work is visualized. To set up a board, a few questions need to clarify. What is the first step on the process? What is the last one? Which steps are run through within the system boundaries? What are the rules that govern the work? See also, these are rules that are explicit. When can a card be moved to the next column? In general, we need to pull, we don't rush. So board column on the side, we have backlog, we have analysis, we have development, we have test, and we have ready for release. These are board columns on the slide. So these are different check marks we can tick and we can write into. Then we have practice 2, we have limit the work in progress, WIP, why and how. Unfinished products are tied up capital. The greater the number of packages started, the longer the throughout time. The goal is to limit the number of tasks that are carried out simultaneously in one work step. Problems without limits, set up times to switch between task bottlenecks are not visible yet. Columns carry limits, example max 5, max 5, max 3. If a limited column is full, only the specified number of cards may be there. If more are actually available, the team must first ensure that the cognition in the test is carried and the flow of work is restored. Not everyone continues with their work, but they work together to ensure that it continues. Only finish work counts. It also means free space on the board so that another work package could be drawn in this area. Once again, pull not push. Then we have practices 3 to 6, manage the workflow, explicit rules, feedback, joint improvements. Manage the flow, meaning that good workflow is characterized by uniformity and predictability. Work on your problems first, equals to everything that causes the workflow to stall, example bottleneck in a step. Before you start new work, communicate several times a day, example daily stand-up. Make process rules explicit. Few rules, but they are followed without exception. The principle of visualization also applies to rules. Make them visible. Rules take emotions out of processes. It is jointly argued what happens if, for example, too many tickets have the status test. Rules are decided jointly. Six is team committed and are changed immediately if they have not proven themselves, for example. Then we have implicit feedback mechanism like daily, retro, etc. We have carry out joint improvements. Start with the current situation and improve it in small steps. A Kanban board is therefore never static. These are the flow, explicit, rule, feedback, and joint improvements. We can evaluate Kanban against 4 criterion. High quality framework is too generic. Explicit iteration, quality assurance practices in the workflow is necessary. Satisfies customer. We can see the point above. Then we have very high transparency of the process and process bottlenecks, maintainability, high exchange of knowledge, cost, limitation of work in progress, its steady pace. Who am I? Match in the motto to its process. Plan everything carefully, it pays off later. Waterfall, so we plan everything carefully, or V model. Take everything to the extreme, XP. I give you a maximum model, you have to adapt it yourself. It's V model. Errors are easiest, cheapest to find at this level at which they are made. V model. It's easiest to find and cheapest at this level. We have V model. Stop starting, start finishing. We really finish something, it's Kanban. Carry out meaningful practices with the necessary intensity. Unified process. Improve continuously. Kaizen. Kanban and Scrum. We improve, these are iterative. So these are rapid fire exact quiz, so we practice it on different side.